distance in feet of an object from a point is given by some parabola, where t is time in seconds. The 0 foot mark can be above ground. I'm mentioning this because, well, this formula doesn't actually start you off at the ground. See, at time is equal to 0, you're starting 5 feet up. So, anyway, whatever. The ground can be anywhere, but you can be throwing an object from somewhere other than the ground. Okay, what is the average velocity of the object between t equals 0 and t equals 5? The thing to remember is typically with these physics problems, s prime is v and v prime is a. Okay, since they give you s and they're asking you for velocity, s is position, and v is velocity, and a is equal to acceleration. Okay? So s prime is equal to 1 minus 2t. That would tell you the actual velocity, but then you say, oh, wait a minute, it says average velocity. So we're thinking way back to exam 1 before we had calculus, so that's all background information, but now we got to kind of go back. What is the average velocity? Aha! This was the formula we were looking for. S of 5 minus s of 0 over 5 minus 0. Right, that was the average velocity. And the way we calculate that, 5 plus 5 minus 25, just chuck everything into the formula, minus 5 all over 5, and that ends up being, sorry, I'm running out of space, minus 4 feet per second. Okay? So all this stuff is useful, but not in this question. Okay? So you can erase all this, but that's what I saw in a lot of people's papers on the analogous question when I graded this question on the final last year. Okay, so I want to kind of point that out. So don't fall into that trap. Okay, the second question is numerically estimate the instantaneous velocity at t equals 3. It's t equals 3. This is a footnote. It is an English grammar mark. It is not a math mark. There's no such thing as 3 to the power of 1. 3 to the power of 1 is 1. So if you look down and you see the footnote, this is a place where you may not use derivatives. Okay, so we want to numerically estimate the instantaneous velocity at t equals 3. So we go ahead and do that, and the way we do it is we use this same formula, but instead of 5 and 0, we do something like s of 3.00001 minus s of 3 over 0.00001. Okay? And so we just figure out what this is, and s of 3 is easy. Let's figure out s of 3 point, and then there's 4 zeros and 1. So we're going to go ahead and use a calculator, but let me write it down first. Here's t, 1, 2, 3, 4 zeros minus 1, 2, 3, 4 zeros squared. Okay, so this one is the calculation intense part of the question. Okay, so the part I'm worried about is this 0.00001. I'm going to type that in incorrectly, so I'm going to be very, very careful. Plus 3.12344 zeros minus, make sure you, well, I guess you don't have to put this in parentheses, but doesn't hurt. There's so often a negative sign floating around that I'm just sort of in the habit. Okay, and then I double check, I enter that incorrectly, and I get, let's count the zeros, we have 4 zeros and a 5, minus 1 point, so we can have minus 1 point and 4 zeros and a 5. So that's important. So now we're going to put all our pieces back together. We're going to get minus 1 point, 4 zeros and a 5, 4 zeros in the denominator. And what's s of 3? You know, s of 3 is 5 plus 3 minus 9. So what's that? 8 minus 9 is negative 1. Okay, that was easy. And but we're going to subtract -1. So it's like adding 1. Here we go. Let's calculate it. So it's it's -1.4 zeros and a 5. And then you add 1, or subtract a -1. I would hit equals here, otherwise you're going to mess something up. I mean, I would. 0.12341. Okay, so count, make sure you have the right number of zeros. Okay, so the answer is -5, and it's feet per second. Now, something you should do before you go on to the next question is you should double check and say, was there any relationship between these two questions? At one point you were saying you're numerically estimating the velocity at t equals 3, and here 3 is between 0 and 5 somewhere. So you kind of expect these numbers to be in the same ballpark, and they are. You have a -4 feet per second here, and you have a -5 feet per second here. It's not guaranteed that that's going to be meaningful, but it's a good thing to check, because if you have something like 1,000 on one of them and 4 on the other, then you probably did something wrong. But I wouldn't be freaked out if the SIGN sign changes, because possibly the object is, you know, going up and then going down. I mean, that's okay, right? So it's okay if these problems with balls in the air, very often it's going up and then it turns around and comes down. So it's okay if it goes from positive to negative, but you don't want the magnitude to be wildly different for these two numbers, because, well, it probably isn't. Now, if you have an exponential function, then you can expect that kind of weird behavior, but not for just a simple parabola when you're really close to the vertex and you're doing these standard problems. So.